you.
Right. Okay, I think everyone is here, so we can get started without any further ado. Now, again, before we do so, a quick formal introduction on my end, guys. If you're new to this session, if this is your first class, my name is Mohammed Shoaib. I'll be a cybersecurity trainer from DURGASOFT for this course called Certified Ethical Hacking. We did take up a demo yesterday, so this is not the first class. I mean, this is the first class for the course, but the demo was taken up yesterday. Okay, so if you have missed out that demo, nothing to worry. It has been recorded and it has been uploaded on YouTube for available for access for anyone. Okay, I'm going to show you how to access that recording as well online. Okay, so by the end of this class. Okay, and again, I currently work as a senior penetration tester. Been there working in this domain for the last 7 years and teaching cybersecurity since the last 5 years or so. With DurgaSoft, at least for the 4 years, at least out of those five. So yeah, we will be talking about the fundamental prerequisite called networking fundamentals today, which is very important for cybersecurity. Understanding what IP addresses are, understanding what important networking protocols are. We'll cover everything from scratch. Okay, so this is the first class in the course. Okay, what we took yesterday was a demo explaining what the course is about, what topics we'll be learning throughout the course, what tools we'll be working on. We have covered all that in the session yesterday. Okay. So let's get started without any further ado. Now, when you talk about networking fundamentals, there are three important definitions to know. What is networking? What are networks? And what are hosts? Okay. So when we talk about networking, it's the concept of basically connecting information devices with each other. So the practice of connecting information systems, any sort of device, your computers, your laptops, your routers, your printers, okay, your IP cameras. So in an organization, the process of connecting all of these devices with each other so that they can share information with each other is called as networking. Okay, having a collection of these devices. Okay, and that collective group of those devices is called as a network. So a network is a collection of interconnected devices that can communicate with each other. So important property, again, property here to note is in a network, every device can communicate with the other device. If a device is unable to communicate with another system, it means they are not in the same network. Okay. So, and every device in this network is referred to as a host. So host refers to any device connected to a network that can transmit or receive data. As mentioned, examples, computers, routers, printers, mobile phones, IP cameras, okay, your smartwatches, smart TVs, whatnot. All of these are individually known as hosts. Okay. Now, just like how we humans have our respective names to address each other, these devices also have names. Those names are referred to as IP addresses, Internet Protocol addresses. Okay. Again, these were invented by the US military in the late 1950s or so. There were multiple versions of it, IP version 1, IP version 2, IP version 3. What successfully worked out was IP version 4, Internet Protocol version 4. And we're still using IPv4 addresses even in today's world. To define what an IP address is, each host in the network is given a unique identity. And that unique identifier for that device is known as an IP address. These IP addresses allow for communication to occur between the hosts. Okay. So when one device wants to communicate with another device in a network, that communication happens on the IP addresses itself. Okay. And this IPv4 address that we're going to talk about now has some important properties to it that we need to know. Okay. So firstly, your IPv4 address is a 32-bit address. What I mean by 32-bit is that it contains 32 zeros and ones in it. Okay. A bit is the smallest data value a computer can hold. It can either hold the value 0 or the value 1. So any of these values, zeros or ones, is called as a bit. Okay. And your IP address contains 32 zeros and ones like this. Okay. And it doesn't have that entire 32 address in one sequence. It is broken down in four equal parts again. Okay. And each of those four equal parts is known as an octet. Okay. Each octet contains 8 bits in it, and this is what that representation looks like. Okay, so you have 8 bits here, which is the first octet. Then there's a dot here, then another 8 bits, then a dot, then another 8 bits, then a dot, and then another 8 bits. So each octet is divided by a dot symbol. So what you see here, this representation again is basically known as binary representation. So this is the language of computers, language of zeros and ones. We humans don't understand this language so easily. So at the first glance, you might not understand what these numbers mean. Okay, but these numbers can easily be converted to human readable numbers as well. So this number 11000000 is actually equal to 192. This number 10101000 is actually equal to 168. This number with all zeros is simply 0. And this number 00001010 is equal to 10. Okay. So now I'm going to explain how do you convert any binary number or any computer readable number into human readable number. Okay. It's quite important to know because from that you'll understand another very crucial feature about the IP addresses. Okay. So let me show you how to convert any binary number into a human readable decimal number now. Okay. Before that, any questions or doubts up to this point? Anyone? I hope the screen is visible. I hope the audio is fine. Any issues with the audio or the video quality? Ashok, Shravani, Nupur.
Sir, could you please speak little loud?
Oh, okay, sure, definitely.
Mm,
Just a
thank
second.
you.
I think there's an issue with the microphone. Is it better now by any chance?
Yes, yes, it is better. Yeah, thank you.
Perfect. Any questions or doubts up to this point, guys? Ashok, any questions? Shravani, any questions? Nupur, any
No,
questions?
sir.
Okay,
Sir,
perfect.
do we have IPv5 addresses as well?
No,
Or it
there's no
is only
IPv5. Again, that didn't work out. Again, there's IPv6 again, Internet Protocol version 6. Okay, a much more updated version. But again, we don't need to learn about that right away. In the upcoming sessions, we'll discuss that, what IPv6 is.
because long years back also when we studied it was IPv4 only.
Yeah, it's been there since a very long time, and we're still using IPv4 itself. They've not
Okay.
exhausted yet. Okay. Although there is still,
Okay.
again, they have invented IPv6 as well. Okay, but not
Mhm.
all the companies have migrated to it yet. Okay, so only few selected companies are running both simultaneously on IPv4 and IPv6. Okay.
Okay.
So again, there's no such company who has completely shifted to IPv6 yet. So moving on, now let's talk about how do you convert a binary, a computer readable number into a human readable number, binary to decimal. Okay. So to convert any binary number to a decimal number, there are two simple steps. So let's say we take this number here, 10101010. So there are 8 bits here. To convert this octet now into a human readable number, there are two simple steps. Step number one, you write down the values of 2 power 0 all the way up to 2 power 7 from right to left. So the rightmost bit has 2 power 0 under it. Then you have 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and then 2 power 7. So from right to left, you're writing down these values as such. Okay. If you ask specifically why 2 power everything, it's a binary number. So again, there's a 2 power everything. You only have two possibilities, ones or zeros. Hence, 2 power everything. Okay. Now, once you have written down those values there, you multiply the lower value with the top bit. So 2 power 0 into 0. And then you add it with the next one. Plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So irrespective of what bit you have on the top, you multiply the lower value with the top bit and you add it till the end from right to left. Okay. So to perform this calculation, let me give you the values for these numbers first. Anything to the power 0 is always equal to 1. It's a mathematical rule. So 2 power 0 is also equal to 1. 2 power 1 is 2 itself. 2 power 2 is 2 into 2. That's 4. 2 power 3 is 2 into 2 into 2, 3 times. That's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times. That's 16. 2 power 5 is therefore 32. 2 power 6 is 64. And 2 power 7 is 128. Now that we have these values here, we can substitute them here and get the final answer. 2 power 0 into 0. So 2 power 0 is 1. So 1 into 0 is simply 0 plus 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. 2 power 2 into 0, 0 again. 2 power 3 into 1, 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. 2 power 7 into 1, 128. If you add all this up, 128 plus 32, that's 160. 160 plus 8, 168, 168 plus 2, 170. So when we humans read the number 170 as 170, the computer reads it as 10101010. That's how it understands the number 170. Okay. This is something like high frequency, high, low, high, low, high, low. So when that exact sequence of frequencies flow through a computer, it understands it as the number 170. Okay. Is that clear, everyone? Any questions regarding the conversion? Ashok, Shravan, Nupur?
No, sir. Thank you.
Yeah. If this is clear, perfect. So if this is clear, I have two more numbers here. If you have a pen and a paper beside you, I want you to convert these numbers to decimal values. 01010101 and all ones. So example 1 is 01010101 and example 2 is all ones. And I've written down the values from 2 power 0 to 2 power 7. Okay. So if there's no confusion, I want you to give me the decimal values for both these numbers. Take your time, no rush. If you have a pen and a paper beside you, try calculating it and give me the final answer. Do not cheat, do not ask ChatGPT. Okay. So if possible, try doing it manually and give me the final answer.
Sir, we need to find the decimal for like all the ones you have written it, right? One, 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 one,
Yeah, for
one, one,
example
one.
1 and example 2. Yes, for both the numbers.
Okay, for
Just like
both.
the exact same way we did
Okay,
it for the earlier one, for this one here, for this
okay.
8 bits here, 10101010. I want you to follow the same procedure for the other two examples as well. Okay. And give me the final decimal value for both of those. Take your time, no rush. And here's a table on the right side to refer back to the values from 2 power 0 to 2 power 7. Any answers, guys, for example 1 or example?
First one answer 85, sir.
85. Okay, let's verify that.
Second one answer 255.
First one 85 and second one 255. Others, have you got similar answers as well or anything else?
So first is 85 and second one I'm still doing.
Okay, no worries. Ashok, any answers on your end? The mic is unmuted, but I can't hear you, Ashok. I think there's some issue with the microphone. I'm unable to hear your voice. Okay, no worries. Let me give you the answer for the first one. 85 is correct, guys. So, right. Right. So again, when we talk about this number here, 2 power 0 into 1, that's 1. Plus 2 power 1 into 0, that's 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, 0. 2 power 4 into 1, 16. 2 power 5 into 0, 0. 2 power 6 into 1, 64. And 2 power 7 into 0, 0. So if you add all this up, 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, 85. Correct answer. And the second one, when you have all ones, you just need to add up everything, right? So, Nupur, have you got the answer? Or shall I give out the answer already?
Yes, sir. It's yeah, we will add every numeric because there will be no zero in that. So it's,
Right.
I think, 255.
Exactly. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So if you add everything, you get the number 255. Perfect answers, guys. That's very rare. Again, usually sometimes answers are wrong, but again, all of you have given the correct answers today. That's perfect. So again, the reason I'm explaining you all this here, this conversion, you would not come across this anywhere in real time. But this conversion now lets you know a very important or an important or a fundamental fact about the range of IP addresses. So now if I have to get the first IP, all I have to do is put, again, basically put zeros everywhere in every octet. Okay. So in the first octet I have all zeros. In the second octet I have all zeros. In the third octet I have all zeros. And the fourth octet I have all zeros. Now when I've put zeros everywhere in every single octet, the first IP that I would have in decimal value is simply 0 dot 0 dot 0 dot 0. And if I have to get the last IP, how do I get the last IP? By putting the maximum value everywhere, by putting all ones. So when I put all ones, I get the last IP as 255.255.255.255. Because for all ones, you've just calculated and given me the number is 255. So no matter what IP address you take in the entire range, in the IPv4 range, first IP would always be 0000. Last IP would be 255, 255, 255, 255. Your IPv4 addresses cannot exceed beyond the number 255. Okay. And if you have to calculate how many IP addresses are there in total, every binary bit here has two possibilities, zeros or ones. And there are 32 bits in total. So since each bit has two possibilities and the total number of values you have is 32, so the permutation formula would be 2 to the power of 32. Okay. Now 2, again, every possibility, 2 to the power of 32 positions. Okay. And that would give you a total of 4.3 billion IP addresses approximately. So when these IP addresses were invented in the late 1950s or so, they thought 4.3 billion IP addresses is a very large number because back then you didn't have mobile phones, you didn't have many people accessing the internet. So they thought 4.3 is a very large number. But fast forward to 2025, the population itself is close to 9 billion people. Again, each person again has multiple devices. So if you assign each singular IP to each device, this 4.3 billion IPs would have exhausted long ago. Okay. To overcome that issue, these 4.3 billion IPs are again divided in various categories. There's something called as classes, there's something called as public and private IPs. We'll cover all that. But before we dive into the categories, let me explain the sequence of IP addresses. Okay. So we know this is the first IP, we know this is the last IP. Let's talk about the sequence. How are the IP addresses progressing one after the other? Okay. To understand the sequence, again, there are two simple rules. Okay. Let me explain them in a simple notepad file. So just a second. Yeah. So we know, oh, sorry. We know that the IP addresses start for the Again, for the IPv4 range, the first IP you have is always 0000. Okay, that's the first IP. Ignore all this, just ignore this for now. Not so important. Right. So now, if you have to get the next IP, rule number 1 is you always start incrementing from the rightmost octet. So here, if I have the first IP as 0, 0, 0, 0, the next IP would be 0, 0, 0, 1. So the rightmost octet is incremented by 1. Okay. Next IP 0, 0, 0, 2. Next IP 0, 0, 0, 3. Next IP 0, 0, 0, 4. Next IP 0, 0, 0, 5. Then you would have 6, 7, 8, 9, 10, 11, 12, 13. Goes all the way up to 0, 0, 0, 255. Now, please note after 0, 0, 0, 255, you would never have a value like 0, 0, 0, 256. This is not possible. This is an invalid IP. Any octet can only go up to a maximum of 255, not beyond that. Okay.
Sir,
So
this
now,
is just one octet, na? We are looking
yes,
at
this is
just
only the
one.
rightmost octet. Okay, no matter what octet you take, it can only go up to a maximum of 255. Now, once this reaches the maximum value of 255, then comes rule number 2. Okay, once the rightmost octet reaches the maximum value, then you move to the left octet. So this 255 cycles back to 0, and the left octet now increases by 1. Okay, so after 0, 0, 0, 255, we have 0, 0, 1, 0. Okay. Now after 0010, don't directly jump to 0020. That would be wrong. Remember rule number 1, always increment from the rightmost value. So after 10, you have 11, then 12, then 13, then 14, then 15, 16, 17, 18, 19, 110. Goes all the way up to 1255. Okay. Then after that, then you have 20. So the 255 cycles back to 0, and this 1 changes to 2. Okay, so you see there's a pattern here from 0, 0 to 0, 2, 5, 5, 1, 0 to 1, 2, 5, 5, 2, 0 to 2, 2, 5, 5, 3, 0 to 3, 2, 5, 5, 4, 0 to 4, 2, 5, 5. The pattern keeps on repeating again and again and again. And somewhere down the line, you would have 0, 0, 0, 0, 0, 2, 5, 4, 0 to 2, 5, 4, 2, 5, 5, then 2, 5, 5, 0 to 2, 5, 5, 2, 5, 5. Okay, so here you would have 0, 0, oh, sorry, 0, 0, 254.0 to 0, 0, 254.255. Okay, then you have 2550 to 255, 255. Once both these octets are full, what happens next? Whenever an octet reaches the maximum value, reset it back to zeros, and the left octet changes to 1. Okay, so you have come back to the first pattern again. 0, 0 to 0255, 1, 0 to 1255, 2, 0 to 2255, 3, 0 to 3255, 4, 0 to 4255, and then again 2550 to 255, 255. Once it reaches the maximum value again, then this 1 changes to 2. So you see, this is the next pattern. 0, 0, 0 to 0255, 255. 1, 0, 0 to 1255, 255. 2, 0, 0 to 2255, 255. 3, 0, 0 to 3255, 255. 4, 0, 0 to 4255, 255. 5, 0, 0 to 5255, 255. 6, 0, 0 to 6255, 255. The pattern repeats that way, and somewhere down the line, you would have 25500 to 255, 255, 255. Once all these octets are full, the last 0 now changes to 1. Okay, and these 255s cycle back to zeros. So whatever repeated here from the first number 0, 0, 0, 0 to 0, 255, 255, 255, same pattern, this entire pattern repeats from 1, 0, 0, 0 to 1, 255, 255, 255. Then 2, 0, 0, 0 to 2, 255, 255, 255. Then 3, 0, 0, 0 to 3, 255, 255, 255. Then 4, 0, 0, 0 to 4, 255, 255, 255. This pattern goes on and on and on. And somewhere down the line, you would have 255, 0, 0, 0 to 255, 255, 255, 255. So here's the first IP, and here's the last IP. Okay. And if you count each and every single IP, there would be a total of 4.3 billion IP addresses. Okay, so this is the same sequence which I've written down here from 0000 to 255, 255, 255, 255. Okay, so understanding the sequence is quite important. We'll be working on this in the upcoming sessions. It's again, it's going to
Sir,
come back.
this is
Yeah.
sorry to interrupt. This is in decimal we are checking now.
Yeah, this is all in decimal. Each octet here is being shown in decimal values, not in binary.
Yeah, got it, got it.
Right.
Because in binary we have like different 4 octet with 810
Yeah, with 8 bits again, with
combinations.
all ones and zeros. So you don't need to use that. We are just directly going with the decimal values here. What we use in our network configurations as well, these are the same IP addresses.
Okay.
Right. Yeah. Any questions or doubts up to this point, guys? Anyone?
Sir, every device has a IP addresses like mobile phones as well.
Yeah, every single information system. Your mobile phones, your laptops, your routers, your switches, your firewalls, your intrusion detection systems, intrusion prevention systems, your printers, every single information system which is connected to a network will have an IP address in this format. Right. So now let's talk about the categories. So as mentioned, this is the entire range, guys. Now this entire range of 4.3 billion IP addresses are divided in multiple categories. So firstly, there's something called as classes. Class A, Class B, Class C, Class D, and Class E. They are the first 5 categories. And again, in each class, there are 2 subcategories. Public and private IPs in Class A, public and private IPs in Class B, public and private IPs in Class C. Class D and Class E are exceptions, only public IPs, no private IPs in Class D and Class E. Okay. So today we're going to conclude the session with what public and private IPs are. In the next session, I'm going to explain about the classes as well. Okay. So to understand what public and private IPs are, we can take the example of our single home network itself. Now in your home network, you have a Wi-Fi router, and connected to this Wi-Fi router, you have other devices, your laptops, your smartphone, your smartwatches, your smart TVs or whatnot. Now this is your local home network. This is also commonly known as the intranet network. Okay, intranet is a local private network. Now, when you have these local private devices and when they have to communicate with each other, they use something called private IPs. So private IP addresses are the IP addresses used within private networks, home networks, local offices, organizations, etc. For local communication, you use private IP addresses. Okay. Now, these private IPs can't directly communicate with the internet. If you want to communicate with the internet, you need something called a public IP. So your router, Wi-Fi router, gets a cable from outside the house, an optical fiber cable or an RJ45 cable or whatever it be. You would have a cable coming from outside the house and it connects to your router. So the ISP guy, internet service provider, Airtel, Act Fibernet, Hathway, whoever, whatever ISP you're using, that guy initially at the setup brings a cable from outside the house and connects to your router. So that cable carries the public IP. Okay. So public IP addresses are given or allocated by the internet service provider to access the internet. Okay. Just with your private IPs, you cannot access the internet ever. To communicate with the internet, you always need a public IP. So public IPs are globally unique IP addresses assigned by ISPs, internet service providers, to have access to the internet. Okay. So if your phone wants to communicate with a website like google.com, it first sends a packet from the phone to the router. This communication, this intranet communication happens on private IP. Your router, excuse me, is capable of transmitting data across 2 different networks. So from the private network, it shifts the packet to the public network. And then using that public IP allocated to your router, it sends the packet to the ISP, internet service provider, and it jumps across multiple different servers on the internet and then reaches the website google.com. Okay. So to define each of these, public IP addresses are globally unique IP addresses used to identify devices on the internet. They're allocated by the ISP, internet service provider, and they're routable over the internet. So every traffic on the internet happens on public IPs. Okay. And to check what your public IP is, you can go to your browser, and in the browser, you can just search for what is my IP. And when you search for that, you get multiple websites here. What is my IP address.com? What is my IP.com? You can click on any of these websites, and this shows your exact IPv4 address. So this is my IPv4 address allocated to me by my internet service provider, broadband internet service provider. Okay. So again, that's what your IPv4 address looks like. And if you observe, all the numbers here are between the range of 0 and 255. No number will exceed the number 255 here. Ignore this address for now. This is IPv6 address. We have not covered that yet. We'll cover that in the upcoming sessions. Okay. So this is what we are again observing right now. Okay. Now, on the other hand, when you talk about private IPs, these are the IP addresses used within private networks. Home networks, offices, organizations, all of these internal devices will use private IPs. So in your home network, if you're connected to the Wi-Fi router, your Wi-Fi router and your phone and your laptop all are communicating on private IPs. Okay. And to check what your private IP is, if it's a Windows-based device, you can open up the command prompt CMD and search here for ipconfig. This command shows your private IP. So this is my IPv4 private address, 192.168.0.5. Okay. So there's a specific range, guys. So every private IP and every public IP has a specific range. And we're going to cover those ranges in the next session. Okay. So each class has a specific range, and in each of those classes, again, there's a separate range for public IPs and private IPs. So this is a much more in-depth concept, and we're going to cover all this in the next session, in the session tomorrow, which will act as our last demo for the entire course. Okay. So yeah, that's that. Nothing further. A brief and a short demo explaining what networking is. So what we have learned today is basically what networking is, what are networks, what are hosts, what are IPv4 addresses, what are the properties of IPv4 addresses, what do this again look like in binary language, how do you convert that binary number to a decimal number, okay? And from that conversion, we got to know what is the first IP, what is the last IP, how many IP addresses are there in total, what is the entire sequence of IPs, okay? And what are the categories of IPs, what are public IPs and what are private IPs. In the next session, we're going to talk about what classes are, what are the specific ranges of these classes, what does each class signify, okay, what is class A, what is class B, what is class C, okay, and what is class D and class E, what is subnet mask, what is, again, how do you assign a private IP, what is the manual method, what is the automatic method from a DHCP server. We'll cover all this in the next session, guys. Okay, so a very interesting class tomorrow, again, a quite complex one as well, but quite important for cybersecurity. Okay, that's what we're going to cover in the upcoming sessions. Okay, now we can have a small Q&A session. If you have any queries regarding cybersecurity or regarding networking, you can let me know, guys. If not, you can exit the session and we'll connect back tomorrow for our last demo class. Ashok, any questions? Shravani, any questions? Nagaraj, any questions? Nupur, any questions? And again, as mentioned, guys, all of these classes are being recorded. So if you want to check where those recordings are, you can go to your browser, search for YouTube, and in YouTube, you can search for cybersecurity DurgaSoft. Search for DurgaSoft, cybersecurity, and filter it by recently uploaded. So just select this tab, recently uploaded, and you get the last demo. Oh, has it not been uploaded yet? No worries. Again, this is the recording from the Sunday's class, from the Sunday's workshop. It's the same thing as yesterday. You can check that out as well. Same content which we took yesterday. Okay. So yeah, that's that. I'll confirm with the institute why this yesterday's recording is not uploaded yet. No worries. That should be uploaded shortly. And yeah, that's that. Nothing much. Any queries or doubts up to this point?
So would you be able to show the like contents of the course, like what all will be covered?
Oh yeah, definitely. 1 second. This is the entire curriculum, guys. Okay. What we learned yesterday was Introduction to Ethical Hacking, the demo session. What we are learning today is networking basics. After this, we're going to go into virtualization. Okay, then Linux commands. Okay, then Windows configurations, DNS server, web server configurations, and then the ethical hacking concepts. information gathering, scanning, network enumeration, system hacking, malware attacks, sniffing, MITM attack, DOS attacks, social engineering, web application pen testing, vulnerability assessment and pen testing. And these are all bonus concepts. Cryptography, reverse engineering, IoT pen testing, Splunk for SOC analysis, and hacking mobile phones. This is the entire course curriculum actually. I think this is
So-
available on the official website of DURGASOFT as well. If not, you can also check the EC Council webpage for the curriculum.
Okay.
These are the prerequisites, Ashok. So again, whatever prerequisites are required, we are learning them throughout the session. And yes, we will have a lab setup as well. So there's a separate class for lab setup installation, if you notice, installation and management of virtual machines. So in that class, I'm going to show you how to install a lab, how to keep it ready for all the upcoming sessions. Okay, so I'm going to explain that as well. No need to learn anything anywhere else. Everything is included in the course. Okay. Is that clear?
So easily we would be able to like download all the tools and necessary.
Yeah, sure, definitely. Again, I'm going to share that exact Google Drive links or the links from where you can download the official softwares. I'm going to show you how to perform the, again, how to download them, where to download them from, how to install them. I'm going to show
So
everything in this
we
session.
would be able to do all the practices there.
Yeah, definitely. You'll have the lab set up on your own device. You can practice at any time. You'll have 24/7 access to it because the lab setup is installed on your private device itself.
Okay. And mostly it is going to be, like you said earlier, it is going to be mostly like 80% practical and
Yeah,
20%
definitely. It's a very
theoretical.
hands-on course. Come, I can guarantee you that you don't have to worry if this is theory nonsense. No theory nonsense. Okay, it's a very hands-on course. We'll learn every concept. Once we start the hacking cycle, all the classes are going to be very practical itself. Very little amount of theory. Once we dive into the actual contents from information gathering, networking, the hacking cycle part. Okay, the first few prerequisite classes are the 20% theory, I would say. They are quite more theoretical, but once we dive into the actual concepts, the hacking cycle concepts from here, from the footprinting class, from here, it's all practical itself. Okay. Very little amount of theory from here. It's all practical hands-on sessions. Okay. Any other questions, guys? Nupur, Ashok, Nagaraj.
Sir, can we have your personal number as well?
Yeah, definitely. The institute will be sharing with that with you. I'm not allowed to share right now, Nupur, but once we are,
Okay.
again, once I have the registered list of students, I'll be sharing my
Okay.
number with you all. I will be having a WhatsApp group as well. Okay. To get the updates regarding the
Okay.
class and the contents of the class. Okay. I'll be sharing the recordings there, the course documentations on the WhatsApp group.
Oh,
Okay. So we will have a WhatsApp group. But again, I'm only supposed to share it once the students have registered, not before
okay.
that.
Okay. Okay. So
Policy.
daily we would have 1 hour class Monday to Friday.
Monday to Friday, 1 hour session every day. Yes. Any other questions? Napur, Ashok, Nagaraj.
No, sir.
Sir, so we would be able to get like fresher to start with, like fresher job with this, right?
Again, definitely. This course is designed in such a way where you, again, for people who are planning to get started in cybersecurity freshly or shifting to cybersecurity from another IT or a non-IT domain as well. So even if you're a fresher, this course will be equipping you with all the tools and techniques and responsibilities necessary to land a job.
Mhm.
Okay. So definitely for people who are just passing out of college as well, this course is recommended to again land a cybersecurity job. This is the go-to course for it.
Uh, okay. Actually, I was working with middleware profile as of now, but recently I have
Oh,
resigned.
okay. Acha,
So
middleware.
yeah, application server support.
Right. Understood. No problem.
So
Again,
I
if
was
you're already
thinking,
in the IT, sorry. Yeah.
actually, I was just thinking to, like, I'm not able to decide whether go for data analytics and for cybersecurity. So
Nothing to worry as such, no. But again, depends on your
actually,
interest. I would not
I
force
just
you, or I
don't
would
want
not
to
tell you.
go into coding or something. So I'm just figuring
Right.
it out.
Nothing to worry. Again, I think recently, a few months ago, there's one more student called Ravi. He was also from the middleware background itself. I think I did
Uh-huh.
help him in creating his resume also the other day. If I think I
Okay.
still have his resume somewhere here. Hmm. Yeah, this guy was also from middleware. He already landed a job, as you can see, middleware administrator.
Okay.
Okay, so I did help him in creating his resume. So no worry, I'm going to assist you on that as well. How do you write your own resume? Create it again, specifically mentioning that you're well versed with cybersecurity concepts. Okay, and all the tools required in cybersecurity. So you can add that. Okay, so this guy just put up a fake a bit. Okay, because he was applying for UK based jobs again. So again,
Okay.
he did had a job with the same post with the same CH training. Okay, and he was from middleware itself.
Because if we show some of the experience in that, then it will be like we can expect the hike from the like previous salary that we were
Right.
having.
If you're already
And if
in IT
we,
domain, there's a possibility of you showing some fake there. If you're not in the IT also, it's not a problem
yeah.
because there will be companies hiring freshers also. So either ways, it's beneficial.
Okay. Okay. Thank you so much, sir. Thank you for all the explanation. Thank
No
you.
problem, no problem. So again, just trying to do my best possible way of explaining all the things clearly. So no worries. If you have any further questions, please do let me know, guys. Since we have a small Q&A session now, you can clarify your doubts.
So last question. We do not have any coding or something in that,
No,
right?
no, no. Again, I can guarantee you that there's no requirement of any coding for this course. Okay. Again, as mentioned, there's no requirement at all. Okay, all the things that we'll be learning are specifically on tools itself. Okay, there's a lot of
Okay.
tools to
Okay.
use. Okay, so I'm going to show you how
Mhm.
to install them, how to run them, how to work around with them. Okay, so I'll explain from scratch. Okay, but again, in all of those, you don't have any requirement for coding at all.
Okay.
Right. Any other questions, guys? Yeah, okay. Thank you. Have a good day. And I'm going to connect back with you tomorrow again for the last demo, guys. As mentioned, tomorrow will be the last demo for us. And please do register at the earliest if you haven't registered already. And the link will change from Monday onwards. Okay. Bye-bye. Good day.
Sure. Bye.
Bye, guys.